Good morning, class. Today we're going to be talking about area of parallelograms and trapezoids. So let's first determine what is the formula for the area of a parallelogram. Remember from yesterday's lesson that the parallelogram lives in the quadrilateral family. What is an example of another parallelogram that you easily know the formula for? And if you guessed the rectangle, then you'd be correct. We use the rectangle a lot. You've known this since the younger grades, that the area of a rectangle is equal to the length times the width. So let's see if our parallelogram here is related to the rectangle in terms of finding its area. And the answer is yes. If I were to cut a piece of the parallelogram here and take him off and move him over to the other side, what shape have I now created? A rectangle. So in order to find its area, when we talk about a parallelogram, we use the terms base and height. Base and height. So to find the area of a parallelogram, we need to multiply its base times its height. Now let me put the parallelogram back here. Notice that the height of the parallelogram is not this left side or this right side, okay? It is going to be the distance from the top of the parallelogram down to its base. The height and the base are perpendicular to each other. Remember, perpendicular means that they will form a right angle. They will form a right angle, the height and the base. So that's my hint to you for the rest of the following chapters when we're finding area and volume, is to always look for that right angle to determine what is the base and what is the area. The two sides extending from this right angle are going to be your base and your height. Okay. So let's get started on our first example. I've already drawn a parallelogram for you, and now I can fill in some values. If I tell you here that this piece is 8, this piece is 6, this piece is 7, could we determine what is the area of this parallelogram? In order to do so, I need to determine what is the base and what is the height. 8 along the bottom here is the base. And remember that the base is perpendicular to the height. So as I look here, if I know that the bottom of the parallelogram is 8, then I also know that the top of the parallelogram is going to be 8 units. Because we learned yesterday that parallelograms have parallel and congruent opposite sides. So I looked for the right angle, I found it. This side extending off the right angle here is going to be 8 units as well, and the height is 6. So I really don't even need 7. 7 does not apply when I am finding the area. So let's multiply 8 times 6. Well, 6 times 8 is 48. So this is 48 units squared. 48 units squared. When you enter in your homework assignment, it will just want the number, okay? So do not include units squared or it will mark it wrong. Moving on, the next problem, the base of the parallelogram is 5 inches. The height is twice the base. Find the area of the parallelogram. Okay. So I've drawn the parallelogram. Whenever you're given a word problem, I find it's best to draw a picture. And let's fill in with what we know. The base of the parallelogram is 5 inches. So I can come to the base of my parallelogram and I will label it 5 inches. The height is 2 times the base. That word twice means 2 times. So I want to find the height of my parallelogram. Remember, the height is going to be perpendicular to the base. So the height here is 2 times the base, which we already know that the base is 5. So 2 times 5 here is going to be 10. So the height is 10 inches. Now if I know the base and the height, I can find the area. Area is equal to the base times the height. 5 times 10 is going to be 50 inches squared. Okay. Before we move on, I do want to make a note about these units. So if I ask you from the distance from this left point across to the right point, if we were going to walk that distance, then your units here, which are inches, would just remain the same, inches. I walked 5 inches from left to right. Okay. And if we're talking about area though, now we're multiplying. So we're multiplying inches times inches, which result in inches squared, okay? So this is not 50 squared. This is 50 units squared. Only the units are squared. So I want you to think of this in terms of when we multiply variables. So think of x. X just has an exponent of 1. But if I multiply x times x, remember from our exponent laws chapter that you need to add the exponents. So this is x to the first power times x to the first power, which is x squared. So if I have inches times inches, that is now inches squared. And volume, which is later this chapter, we're going to be multiplying 3 variables. So this is going to be inches cubed. Think x times x times x, which would produce x to the third power. Now let's just discuss the trapezoid. Okay. To determine its area, let's first take the look at a basic trapezoid here. I want to see if I can relate it to our earlier discussion on parallelograms. So look at this trapezoid. If I can take this exact same trapezoid and flip it over here and add them together, what shape now do you see that I have formed in total? And if you answered a parallelogram, you would be correct. So let's see if we can determine the formula for a trapezoid based on this picture here. So it does look like a parallelogram. Let's look at the bases. Here's one base of my trapezoid. So we'll call this base 1. But when I flip over the other trapezoid, I now have another base, which is a different length. Notice here, this is a smaller base than the first base. So we'll call this base value base 2. So if I add base 1 and base 2, then that will give me the total base of the parallelogram. Remember from the parallelogram formula, you need to multiply the base times the height. So I can create a height here. Okay. The height of my parallelogram is always connected to that right angle. So to find the area here, I need to first add the bases, base 1 plus base 2, multiply it by the height. However, we're missing something. I don't want 2 trapezoid areas. I just want one of the trapezoid areas. So in order to just have one, I then need to divide by 2. And so that is the formula to find the area of a trapezoid. Let's take a look at this next example. Okay, I filled in the trapezoid with the values, and let's see if we can determine what these values are to use our area of a trapezoid formula. Okay. Let's first determine the bases. Remember, bases are going to be perpendicular to the height. So here I've identified the right triangle. So I know here that 9 centimeters is going to be one of my bases. We'll call that base 1. Notice that this is also perpendicular to the top side of the trapezoid, which is then going to be base number 2. And so 2.5, this is 2 5/10 here, is going to be the height of the trapezoid. We do not need this value of 6 centimeters at all, okay? It is not used in relation to the area of the trapezoid. So now that I know what base 1, base 2, and the height is, I can plug those values into my trapezoid formula to calculate its area. Okay. The area is going to be equal to, we have 9 plus 4, multiplied by the height, which is 2 5/10, then divide by 2. Remember from our order of operations, we need to evaluate the numerator first, and then the last step will be to divide by 2. So 9 plus 4 is 13. We need to multiply that by 2 5/10, then divide by 2. 13 multiplied by 2 5/10 is going to leave you with 32 5/10 divided by 2 with a final answer of 16 25/100. Okay. 16 25/100. And this one did give you units, which is centimeters squared. So 16.25 centimeters squared is the area of this trapezoid. In the next problem, the height of the trapezoid is 6 meters. One of its bases is 8 meters. If the area is 54 meters squared, find the other base. So when given a word problem, I think it's best to always draw your picture and fill in with what you know. You know that the height of the trapezoid is 6 meters. So we can draw our height line in our right triangle as our reminder. The height is going to be 6 meters. One of the bases is 8 meters. It doesn't matter which one you pick because we're going to be adding them together. And we know from the commutative property that when we add, the order doesn't matter. 2 plus 1 is 3, and 1 plus 2 is also 3. So I'll call this one here 8 meters. And I know that the total area is equal to 54 meters squared. So what's missing from my trapezoid formula? It's going to be the other base here. And when you don't know something, you should use a variable. So I will choose to use x. Now that I have all of my values listed, let's plug them into the formula. So I have the area, which we said is 54. 54 is equal to my bases. So I have one base is 8 and the other one is x. 8 plus x multiplied by my height, which is 6. And then I will divide by 2. Okay. Then I will divide by 2. Clear up some space here. Now I have an equation that I need to solve. So we need to think back in our memory bank of how to solve these types of equations. Remember, our goal is to isolate the variable, get x by itself. So we need to work outwards, inwards. So you will notice here that I have a fraction. To get rid of a fraction, fraction is division. The opposite of division is to multiply. So I will multiply both sides by 2. Okay? 2 now divided by 2 is 1, so they will be eliminated. 54 times 2 is 108. So now I have 108 is equal to 8 plus x times 6. Okay? Now there's two ways to go about solving this, and I'm going to show you both of them. Okay? You can choose your preference. Some of you may notice here that I could use the distributive property, right? And I could distribute this 6. So then I would have 108 is equal to 6 times 8 is 48 plus 6 times x is 6x. Now I will solve by subtracting 48 from both sides. 48 minus 48 is 0. 108 minus 48 is 60, which is equal to 6x. Divide both sides by 6. And so the answer is x is equal to 10 meters. Okay. There's another method that you can use to solve this, which if you have 108 is equal to 8 plus x multiplied by 6, then we're not going to use the distributive property. We're going to consider 8 plus x to be one term. So when you multiply one term by another, the opposite of multiplication is division. So the opposite of multiplying by 6 can be to divide by 6. 6 divided by 6 is 1. So now I'm just left with 8 plus x unit by itself. And then 108 divided by 6, which is going to leave you with 18.
Okay.
Now we can easily solve by subtracting 8 from both sides. And you will be left with x is equal to 10 meters. Okay, x is equal to 10 meters.
Okay.
So either one of these methods will lead you to the answer. My preference is the first method. Notice here that now we're dealing with smaller numbers, 18 and 8, as opposed to 60 and 40 and 108. So I think it makes it a little bit easier, but either way, we just proven that you'll get the same answer. In this last example, we're going to talk about composite figures. So here I have a desktop. If we want to go to Lowe's or Home Depot and purchase some wood so that we could build a desk, I want to know how much square feet should we purchase in order to build the tabletop for this desk. Okay. Now notice here that this desk is in the shape of a polygon. It's a closed figure made of straight lines, but it is not any of the ones we've talked about. It is not a triangle, a parallelogram, or a trapezoid. So how can we find the area of this? And when you have a composite polygon like this, which is when you take more than one figure and you merge them together to create some other funky looking figure, we can then decompose it. And decompose means to break up into parts in order to find its area. So pause this video, see if you can find where we could decompose this composite figure into 2 or more figures that we do know the area of. There's multiple ways to do this, but I'm going to draw a line from this angle to here. And now I have decomposed this into two trapezoids, trapezoid A and trapezoid B. So if I want to find the total area of the desktop, then I just need to find the area of trapezoid A and trapezoid B and add them together. So trapezoid A plus trapezoid B. Okay? I will start with trapezoid A. To find the area of trapezoid A, remember that area is equal to base 1 plus base 2 multiplied by the height divided by 2. So let's find the bases. When you're looking for the bases, find the right angles. Find the lines that are perpendicular. Notice here that I have a right angle, and so off of my right angle will be my base and my height and my second base. So the bases here will be 5 plus 8 multiplied by the height of 3, then divide by 2. 5 plus 8 is 13. 13 times 3 is 39. Make sure that you add first and then multiply. Okay, the order of operations matters. Parentheses come first. Then it's 39 divided by 2, which would leave you with 19 and 5/10, or 19 and a half feet squared. Okay, and that is the area for trapezoid A. Okay, the area for trapezoid B, the same formula, base 1 plus base 2 multiplied by the height divided by 2. Okay. However, we need to do a little bit more thinking with this trapezoid, okay? We need to find its height. So I have one side here, another side here that are parallel. The parallel sides are the bases. So 9 feet could be base 1, 4 feet could be base 2, and if I draw a line in between them at a right angle, that's going to be my height. Now, do I know the height here? And the answer is yes, I do, but I gotta think a little bit to get there. I know that the total distance here is 8. I know that the shorter distance is 5. If the total is 8, the short distance here is 5, then how much is my height going to be, which makes up the rest of it? Well, you need to subtract. 8 minus 5 is 3. So the height of trapezoid B is going to be 3 feet. Let's plug in these values now. Okay. I said my bases were 9 plus 4, multiplied by the height of 3, then divided by 2. 9 plus 4 is 13, multiplied by 3, divided by 2. Okay. 13 times 3 is 39, divided by 2, which again we came up with 19.5 feet squared. So in this problem, the two trapezoids did happen to have the same area, but please be careful that in your homework problems that when you decompose your figures, they will not have the same area. So you cannot just duplicate it, okay? Forewarning. All right, so now if I want the total area of my desktop, then I will need to add 19.5 plus another 19.5 for a grand total of 39 feet squared. 39 feet squared. Okay, I hope you're enjoying my videos. If you have any questions, or if you have any, if you'd like me to make a video on a topic that you don't understand, then you can reach out, email me. Again, if you need help on a homework assignment or getting on the assistant's webpage, please text me, call me, or email me. Do not leave a comment, okay? Have a good day. Bye.